Okay, so my name is Mats Sjöberg, and I work as Laura already said, as machine learning specialist at CSC, which is the Finnish National Supercomputing Center. And I will talk about the Green NLP project. So why do we need Green NLP? So first, in case the term is not familiar to you, NLP here refers to natural language processing. So this is the academic field that is looking at how to, with computers, process natural, that is human language. And of course, that's the academic field that has given us the large language models that are behind products like ChatGPT and so forth. So as you probably know, and as has been discussed, the current AI boom is quite to some large extent driven by these large language models. So, and you can see here in my slide some graphs that show the exponential growing scale. So the data sets, and mind that this is a logarithmic scale, so it looks linear here, but it's actually exponential. So over the years, that has exploded, the size of data sets and also the size of the models, or I guess this graph shows how many floating point operations are required, but that's similar to the size of model, of course. But those have been really driving and exploding in scale. And then this, of course, as has been mentioned here, has been growing the carbon footprint of these methods. So picture here is actually from 2020, so that's before the AI boom. So the predictions are even more dire these days, I would assume, about the explosion of the energy requirements of this field. So, for example, training the GPT-3 is estimated to have been 350 GPU years. So if you have only one GPU, it would have taken you 350 years to train that. So that would be equivalent of about 1 hour of an entire nuclear power plant block, according to that one estimation. So, and this is of course assuming that you are training it once, but of course, as those who are practitioners of machine learning know that typically you do a lot of uh, hyperparameter tuning and finding the right model for the job. Another bad thing about this quite astronomical computational costs, not just for the training, but also for the usage, is this high centralization. So we end up with a few American big companies are running the services, and everybody is kind of stuck in using that. So this is another negative side, especially from European point of view. And the other thing, of course, is privacy, and that they are then collecting the data, for example, from European consumers into one place. And another European interest is, of course, that Europe has lots of small languages, so it would be nice to be able to support them, not only English. So the Green NLP research project that I'm kind of representing here. So we have the three research partners. So University of Helsinki. So this is Professor Jörg Tiedemann's group. He's the project coordinator. And University of Turku, or the Turku NLP group, led by Professor Philip Ginter. So these are the two of the leading NLP groups in Finland. And then CSC, my employer, IT Center for Science. So it's the Finnish Supercomputing Center. And then here our PI is Dr. Aleksi Kallio, and the AI and Data Analytics Group. So we are not a research partner, so we are not directly doing research, but we are of course supporting the project from the computational resources point of view. And there you can find a link to our website as well. And yeah, this is a small or mid-sized project supported by the Research Council of Finland. So what are we doing in the project? So of course, two big blocks of the training of these large models is the data and the actual training. So one part of the project, we are looking at data curation. So Simo already mentioned that, for example, using less data. So by cleverly selecting data or looking at what are kind of redundant parts of the data set, these are things that we can do there. And then, of course, efficient training, which includes quite a lot of things like the whole training pipeline, how to load the data, how to do things in the most efficient way, so we are not wasting resources. And of course, the computing infrastructure itself. So where does the actual energy come from? And what can we do with the kind of byproducts of that? And then, of course, once your model is trained, you have to use the model. And there are things that we can do. For example, even though the trained model can be huge, we can do things like compacting the model, so distilling it to a smaller size, for example, so that then you can run it. You don't necessarily require a supercomputer to actually run the model. And then the other aspect is, of course, reusing the model. So quite a lot of work is based on taking a foundational model and reusing it somehow. And then the other aspect is reusing the expertise. There is a lot of hidden knowledge about what are the best ways to train a model. And if we could learn from that, we would have less need of having to retrain and correct mistakes, which use a lot of resources when you are training these huge models. So, of course, models should be reusable, but another aspect is to have modular models. So parts of them can be reused again, or we can kind of modularize the models. And then packaging and documentation. So things like making the models easy to reuse, and then also documenting the steps, how we train them, what we learned, and these kind of things. So these are all things that we are addressing in this project. So I will now have like a slide or two about each of those aspects. So for the data curation part, so of course the principle, old adage is that if you put garbage into your model, you will get garbage out. So improving data quality is something to get better models and also more energy efficient if you are kind of remove things that don't benefit the training. So for example, selection, removing duplicates and things like that. Other things can be done, for example, curriculum learning. So this is about the same as for humans, that there is a like in what order you learn things can affect how well you learn. So this is something we can do as well for machine learning. Present training samples in the best order. For example, start with the simple things and move slowly to harder things or something like that. And there is this Opus ecosystem where the research partners in the project are then publishing data sets that have been cleaned up and are good for training models, NLP models. The other aspect from my previous slide was efficient training. So something that especially we at CSC are looking at is the bottlenecks in the computational pipeline. So this is the pipeline where you load your data, maybe from a file system or over the network. Then there is some pre-processing, maybe in the CPU, and then going to the GPU. And here can be many places where, for example, the file I/O or the pre-processing is stalling, and then the GPUs are not being used efficiently. This was also mentioned in Simo's talk that the thing that can be done is mixed precision training. So some parts of the neural network doesn't have to be a full numerical precision. So this is something can be done, and the results are still quite good, even though you reduce for example, from 32-bit floating points to 16-bit. Something we have been working on at CSC particular is to have tools for monitoring the GPU usage so that the users can see, okay, my job that I ran in the supercomputer, it uses so and so much energy. So that's useful when you are optimizing things. And the other aspect, especially recently, where we have people training these large language models, that present some special challenges when you are scaling up even to thousands of GPUs. So this is the case where the model is so huge that it doesn't fit into a single GPU. So you have to split the model itself over several GPUs. And then how do you make the whole pipeline so it's efficient and GPUs are not idling while waiting for data to come in. So another aspect, especially kind of from the CSC point of view, is the computing infrastructure itself. So we have several supercomputers. Here I will talk mainly about the LUMI, which is the Euro-HPC joint undertaking, but CSC is hosting it here in Finland, in Kajaani, and it's Europe's fastest supercomputer. There you can see a picture of the cabinets, and it's the fifth fastest supercomputer in the world. And here you can see the former paper mill in Kajaani, Renforsinranta Business Park, where it is located. So this used to be a paper mill that was shut down, and it has excellent energy and is quite suitable for hosting supercomputers. So from the green NLP point of view, the nice thing is that it uses 100% renewable electricity because of, you can see there the flowing water, which provides the hydropower, and then there is also the wind power. What is maybe even more special about LUMI is that it uses water cooling, and then we use the heat recovery. So the water that comes in to cool down, mainly the GPUs are producing heat. Then of course you get very warm water out from there, and this is actually then pumped into the local district heating network in Kajaani. So to my understanding, there are hundreds of households in Kajaani which are heated by this water that has been heated up by GPUs. So at least you can say it's one of the world's most expensive water boilers. In LUMI, quite a lot of these large language models have been trained. So here are just a few news items from the FinGPT. It's the old Finnish language model, and now they are working on this Poro model, which is even larger one, and then also Allen Institute was training this Olmo model. And this Olmo paper in particular has this nice table which compares the carbon emissions of the different large language models, and they highlight here that the version that they trained in Lumi is 0 or close to 0 if you count in the fact that of this how eco-friendly it is uh, with the energy reuse there, or heat reuse. So the next thing was this to use compact models. So again, this kind of old saying was that training is expensive, but using the model is cheap. And as the previous speaker said, this is no longer true. So this big large language model might actually require multiple GPUs just for the inference. So one thing we can do is this model distillation. So we try to make models that are smaller. And one algorithm for this is the teacher-student model. So you have first the teacher model, which is a huge model that we have trained, and then a student model that tries to kind of copy its behavior, but it's actually a more compact model. So you can train a student model, for example. And then some literature can show even 10 to 40 times compression with some quite small loss of accuracy. And these kind of models can then be run in your on-premise or maybe even in the mobile devices. So you don't need necessarily to use it over the network in some big American corporation servers, for example. And of course, here we can also use this low precision quantization, like going down to smaller bit amounts. Then we have the modular NLP. So this is in particular for the translation side. Our University of Helsinki partner especially are working on machine translation. So very simple example is to use specific encoders and decoders for different languages. So these are can be considered as modules, and then they have a common path in the middle. So then more advanced things are like sharing at other levels components. You can see here, for example, idea would be that, for example, Romance languages like French and Spanish might have their own paths, but they might also have a shared path, so that we are not training everything separately, but we can use modularity in this way. Now this picture shows a few ideas how you could use modularity in the translation case. And there is again a Mammoth framework which implements these ideas if you're interested. And then, of course, on the reuse and sustainability side, so of course, kind of obvious these days, at least from the researcher side, is sharing codes, open source, and then, of course, sharing documentation and all this silent knowledge that I discussed. So this is something we are working on in the project, how to share this. And we are partnering with Hugging Face company. They have a hub where you can share models and data. And on the CSC side, we are working on this machine learning guide, which is the idea that this would be one place where we document how you can train models on our supercomputers. I also wanted to show an example. I realize a bit running late on time about this Poro model, which was one of these big models trained on Lumi.
Yeah, so if you could wrap up now, so
yes,
yeah, great.
So so it's a 34 billion parameter model trained on Finnish and English in the Lumi. And this was done in particular in the Turku NLP side. And it's quite a big improvement over previous Finnish models. And you can check there the paper about it as well. And this is one example of this focusing also on local languages. So for my conclusions, as we mentioned, this AI boom is really driven by large language models. So this is why green NLP in particular is quite an important thing. And we mentioned the downsides. And this last thing here shows kind of overview of all the aspects of training and using model that we are focusing on. And finally, there is the link to the project website.